closer. Yeah. So let's have a round of introduction. So to start with, I am Amartya Mukhopadhyay from the Indian Institute of Technology, Bombay. I am a professor there, and my research is on batteries, focusing on the advanced chemistries from materials, electrochemistry, cell development. In addition to that, it's just earlier this week itself, we registered a spin-off from my group. That's a startup called Volt Ionics Energy. So energy is stored by ions. So that's Volt Ionics. So the registration formalities were completed earlier this week itself. And this is the probably the first platform I'm announcing it. It's not even there on my LinkedIn page as of now. And so as part of the startup, we will focus on developing sustainable, low cost batteries, and so achieving the same performance level as the more advanced batteries as we know today, with greater safety and of course low cost. So that's based on the innovations we have made in the processing and the materials. And of course I have the privilege of moderating this session today, and which promises to be quite interesting with all the panelists that we have. And let me pass it on to my panelists for a round of introduction. Please, Guru.
Hi, sir. I'm Guru Pungavan. I'm the CEO and founder of Boson Cells. We are manufacturing lithium-ion cells right now. We are into the sector of drones. We are manufacturing higher density cells right now and higher discharge cells. And we are planning to divert into the EV side for the low-cost cells and the safety standards required. Yeah.
Good afternoon, all. Nice to be here. Very relevant topic. My name is Pramod Nanjundaswamy, and I head the global delivery for automotive and mobility in Cyient. We serve across tier 1s, OEMs, as well as the ecosystem partners to bring in the talent and then services and the technology that is needed to make this product from end-to-end perspective. I've been in the industry for 25 years, worked with companies like Bosch, Visteon, and even semiconductor companies. And that's the experience that I bring here, both from manufacturing, AI, as well as the software angle to the discussions. Looking forward.
Yeah. Good afternoon, everyone. This is Kavita Verma, MC Systems. We are 100% subsidiary of Endurance Technologies, a big name into the automotive components industry in India. So we are the market leader for two-wheeler, three-wheeler, the automotive components, and also entering into the four-wheelers. So at Maxwell Energies, we are pioneer into the advanced electronics, and I'm glad to be here. Thank you, Amrita. Thank you, Olivier, for inviting us for here, and looking forward to the session.
Thanks, Kavita. So today we have a battery expert, a software automation expert, and a BMS expert, all that we need. We need many more, but at least we have the core today here. Right. So we can start with a very generic discussion. And since I have right beside me Guruji, who is among the leaders or pioneers for developing high energy density lithium-ion cell in India, goes on, right? Yeah. So can you discuss or tell us about the lithium-ion cell manufacturing scenario in India and the challenges? So it's quite intriguing that we don't see too many battery cell manufacturing in India. We don't have too many gigawatt hour lines as of now. So what are the challenges? Are we doing something wrong? And when do we expect the battery cell manufacturing in India to really go up?
So, as you said, right now we are itself at 0.8 gigawatts, and there's not much gigawatts right now in India. The reason behind it, mostly it is reason out to be the raw materials. But what we have seen and gone through right now is the refining stage that is not implemented in India right now. The refinery of the minerals or the salts, which is not implemented in Indian infrastructure or the supply chain. I think the growth of that would exponentially have a growth on manufacturing of lithium-ion cells as well. And in Boson right now, our initial venture was to recycle the end of life batteries and retrieve the salts. And right now we are forward integrated to manufacturing cells. I think that is the reason that boson is able to give low cost cells in the drone fields right now. And we are trying the possibilities of giving low cost cells compared to the Chinese cells in the EV sector as well.
Like, Pramod, do you have any views like what are the challenges like Guru mentioned? Maybe a few more if you're aware of.
Yeah, one is of course the scale and the competency becomes a challenge, right? So not many companies, as you know, and even globally also, everything is now more or less is from China, and developing something locally needs a lot of capex investment, and also the market. That is like it's always the chicken and egg problem, right? Where is the market? Who will buy from me? And what is the end visibility? So unless you have that end visibility, then investing such a huge capex is a challenge. So that's where first problem comes, and everybody wants. If you look at any OEMs or any tier ones, they just want to bring from China and they build body on top or act like a vehicle integrators than ground up development, right? So that's where even if any company is taking that giant step and courage is enough to invest, one is again technology availability, skill availability, and then scaling that to a level that is needed, and then the market availability and support needed from the market. And the third main thing is also, I think again, looking at the global restrictions that have been put, the geopolitics that plays out, right? Raw material availability, all that becomes a challenge. And if it is a startup, your everyday matters for you, right? Because you have to run the system every day. You have put money and make it work. And if production starts for a month because of a shortage of raw material, particularly the lithium or cobalt, nickel, these kind of raw materials, they all come from China. Then how do you sustain, right? That becomes another challenge. So that way, it is according to me, tough market. If you are trying to build that, taking that step ground up, and it's just like any other startup. Stick to the ground and make it run, and then there will be ups and downs, but eventually you will get there.
So we heard a few phrases like geopolitics, lack of raw materials in India, sustainability. So we will come back to that. Before that, let me hear from Kavita if she has views on that. Since also since she is from Maxwell and which is well known for the BMS, I would also request her to elaborate on. Okay, we have the cells, we have the battery pack. Then what about the advancing the vehicle to grid integration? So if you can also start talking about that, then we can take it forward.
Sure. See, when we are talking about vehicle to grid, first of all, it's not only the technology upgrade. We all need to actually accept that there has to be a mindset shift which is needed when we are talking about vehicle to grid in the EV sector. In simple words, what it means that with the V2G, we are talking about that the vehicles, electric vehicles, are not only the passive energy consumers. They are becoming the active energy assets. So, how, I mean, we can withdraw the electricity from the electric vehicle to the grid. So, this is the kind of mind shift which is coming up here. And this is putting up a lot of potential right now in the industry, basically to bring the grid balancing, to actually um, reduce the dependency on the whatever you are plants, fuel plants are there, and it is also generating a totally new revenue stream as well for the especially in the fleet management. So when I talk about from EMS point of view, see, for B2G to actually scale, it requires two bigger parameters. One is the very advanced battery management system, and the second is the your grid infrastructure. So if we talk about from the battery management system, what role it plays, which we are already doing at the Maxwell, basically having the machine learning and the AI enabled algorithms which can tell the battery when and how to engage with the grid management point of view. So this is something which is actually leading us to the thought that electric fleets, they can become like a power distribution system. And again, to play to the maximum optimization efficiency, you need to have the battery management system like that. And we are already doing the piloting with the e-fleets, where we are seeing that the initial results itself telling us that there is a 8 to 10% additional earnings which can get per vehicle. And this is what actually making us think that it's not now only about the mobility, but it's also about the energy resilience. And that's where, I mean, together along with the Maxwell, we are also participating on this part, BT2 sector, and India has a very great position to actually lead in this sector as well.
Fantastic, thank you. So you brought in the terms here, AI, software, etc. So now with this, I am excited to move to Pramod, who has been working on digitalization as well as AI. So how can AI automation in general, how can the advancement in these areas influence the manufacturing processes, especially if you can talk in the context of manufacturing of EVs or batteries?
Yeah, definitely. I'll first talk how generally AI/ML in any sector, like including battery, helps. First of all, we have something called digital twin, right? That means the entire layout of the factory can be virtualized and simulated, and that's how we work with majority of our clients to see what is the most optimal way of setting up the factory so that the space, the lines, the flow of material, and then the entire process flow works in a more efficient and better way. That helps from a turnaround time of the manufacturing, as well as cost reduction, and bringing more efficiency and making it more methodological and systematic as well. That is one part of the contribution. And then specific to battery itself, right, there are a lot of things that happens. One is predictive control. For example, with the algorithms, we can always see if a machine is going down, or based on the vibrations, acoustics, visual inspection. How do we ensure that we proactively predict a machine getting into a servicing mode and prevent that, so that the downtime of the factory is reduced or prevented also, so that anything from a AI/ML usage of continuous running of the factory is ensured. The third thing is adaptive control, like some of the materials, whether it is electrolyte or all that, right? These are again a shortage in quantity. So we have to ensure the wastage is less. So using AI/ML and more robotics enabled factories, what happens is those materials are used in a precise manner to the quantity that is required, so that the wastage is less, and to the right level of usage, so that overall the cost and the efficiency of the battery manufacturing increases. That we call as adaptive control. And then there is also in terms of how do we make sure the overall staging of the machines, the process is optimized in such a way that we build more or less the gigafactories, right? That more does end-to-end battery rather than a part of it. So that way, the inventory control, automatic inventory control, automatic floor control. So all this happens in a closed loop with neural network, with AI/ML algorithm, so that overall factories run in a more efficient and more cost-less manner, cost-reduced manner. And that's what AI/ML plays a role. Right?
Yeah, fantastic. That also makes me interested to know. See, we some of the very important aspects of battery and usage is the state of health, right? Then end of life, which we have various electrochemistry based models which can predict that. So how good or how helpful will machine learning be in predicting them, probably in a better way?
Yeah, so that's where I think BMS is one major system that plays a role. the AI algorithms with the temperature of the cells, right? Ensuring that they don't go too up, too down, and maintain that. And then also, if any particular cells goes bad, monitoring individual cells so that they don't. Anyway, one rotten apple can make other apples in the basket rotten, right? So that kind of a influence is avoided, and they are disconnected from rest of the battery. So and then there are things like discharging and charging control, so that it doesn't go too high, too much discharge, or too much charging. So the charging level control. So all this plays a major role. One, to ensure the longevity of the battery life, and the second thing is also optimization usage of charging and discharging, right? And again, drawing power from the grid when the cost is low, when high more power is available, so then only the power is drawn. Or when cost is high, you give it back to the grid so that you make money out of it. So these are the things where the charging discharging unit as well as BMS plays a major role on when to draw, when to charge, when not to charge. And also based on the parameters of the sensors, we maintain the life of the whole battery so that the range and the life are kept optimal.
So that's at the pack level. Anything at the cell level, like the state of health of a cell or the end of life prediction of a cell?
Yeah, so those algorithms are there, which helps us to, as I said, predict individual at the cell level itself. So that when we know a particular cell is going down, we can even warn back and say that cell has to be replaced, or a cell that cell is disconnected from rest of the batteries, so that the that doesn't pull down the overall battery efficiency. So these kind of algorithms work together. You want to add?
So, yeah, exactly. See, BMS, even though the battery becomes the heart of the EV vehicle, BMS, we always say that this is the brain and the nervous system of the vehicle, which actually tracks all the parameters just now explained. And in normal layman's languages, any user goes to buy an EV vehicle, they have the normal question, how long my charger will last, right? Charge will last. Is it safe to use the EV vehicle? See, those are the very, very basic questions when you talk about the Indian climate and environment conditions. That's where the BMS actually comes into the picture. And we talk about the smart BMSs, very intelligent BMS, and all these are having their back in the back end, all the algorithms which control the state of health of a battery. And when we talk about the state of the health, state of a charge of a battery, it goes to the cell level itself, right? So all the parameters, that's where the BMS becomes the brain.
Perfect. And so all this tells me that, okay, the hardware is extremely important when it comes to BMS. So what about the software? Are you all into the software development, improvement, and how software can help optimize this?
Absolutely. I mean, when we talk about any device, it is not only the hardware, it is how intelligent you make your device. Let's talk about the battery management system. See, at Maxwell, okay, we don't see only hardware problem to be solved, but we see the opportunity on the software side because see, you deal with many cell configurations. A lot of things are coming up in the battery also. You talk about LFP, NMC, and now these, we are talking about the solid state, sodium ion, right? A lot of configurations are changing right now. So, configurations may change, but your algorithms behind this state of health predictability, your charge balancing, they should adapt dynamically. And that's where your software comes into the picture. And at Maxwell, we actually come up with a very modular architecture, scalability, and that's where we are able to scale our BMSs to even from the lowest voltage to the energy storage systems.
I always feel it's not just the EVs, but we should also develop very good, robust, and sustainable batteries for grid energy storage. Right. Okay. So with this,
I'll just add to the
Yeah,
software
please.
part.
Yeah.
While she covered the algorithm, see, functional safety becomes very important, right? That means that software has to be reliable. It can't be any other software that can reset itself. So that's where it is ASIL D level. And mostly we do it model based so that it can be tested, and it's more modular so that it works with any of the configuration. And that third thing becomes important also is cyber security, because again these are safety critical systems and are prone for hacking and everything. So ensuring that cyber security becomes part of the entire system, and these are secure software boot enabled systems also. So that is another important aspect that becomes a critical aspect here.
Right. Fantastic. Thank you. So now let's change the gear a bit. Let's move towards near future, if not really future. So lithium-ion batteries, the LFP chemistry is also NCN, NMC chemistries, as we know. So they are being taken up by electric vehicles in a big way. Different countries have different preferences. That's all okay. Now, but one should not reach a saturations, and there are problems associated with, say, availability of raw materials in a given country, geopolitics, etc., as we discussed in the beginning. So to address all these, what can be the advanced battery chemistries? It can be advanced lithium ion, it can be solid state, it can be sodium ion, which promises to be cost effective, sustainable, can adapt to various temperature conditions, can be very good for fast charging. So all these things are there. So let's hear from Guru his perspectives on the next generation battery chemistries, especially for EV applications.
Yes, sir. So right now, as we can see the trend being from the lithium ion, right now we have transferred from the graphite anodes to silicon anodes, which is being utilized and commercialized as of right now. I think that is the next stage for the lithium ion side. And regarding the chemistries like LFP and the NMCs, I think high range nickel content and low range cobalt content would be a good s- part to be taken into account. And taking into the account of the solid state batteries, I think in the laboratory scale it is feasible and it has been proven, but in the manufacturability there are more constraints regarding that. I think that is yet to be solved and yet to be scaled up. And I think coming, as you said, the sodium ion batteries most commercially and scalable future that I see. Because sodium ion is the raw material wise and the safety aspect and the cost wise gives a high potential to take over the LFP and the NMC's market.
Right. Fantastic. Now, so sodium ion looks very promising, and of course, there are a lot more improvements that need to be done, but I think all those are very much possible. So that's definitely the next generation chemistry for not just stationary but EVs, as I feel. Now, so in general, the lithium ion cell manufacturing and the next generation cell manufacturing, if we have it in a big way in India, will that help reduce India's dependence on the imports and help India become more self-sustaining when it comes to battery technologies and EVs? What's the view? I will go one by one.
Yeah, I think that rather than improving the manufacturing of the lithium ion cells, right now I think India has to mostly focus on the refinery of the materials. I think that is the base that it is required for India as of right now, because the ample amount of electronic waste that is available in India, I think refining that would be a good potential and a ready market available in India right now. And I think that would be the first stage that we have to look into. And the second stage being as we have to be the front runners of the new chemistries or the new technologies in the cell stage, which we are looking mostly into the sodium ion and then the next generation of sodium ions. I think that is the way to go.
Thank you, Pramod. Your views?
Yeah, so I would at least see those two as two parallel activities. Of course, the raw material and its extraction and dependency with China coming down is critical, because we may do anything in the end if we are importing raw material and cells from China. And knowing the history of being very unreliable support system from that side, it makes sense for us to be self-reliable. But at the same time, in investing in the infrastructure, it could be first cell making and then battery making as an integrator. And of course, software is our strength. So making those BMS systems that are made customized for Indian both infrastructure and grid systems, as well as for the India customized battery manufacturing companies also, would be a good end-to-end value add that we can create to this ecosystem, and that will definitely bring the cost of the vehicle down, and that way drive the market demand as well, which is currently the biggest barrier according to me for enabling the demand that is needed for this market.
Fantastic. So, Kavita, if you can start with like some your views on the self-reliance of India when it comes to batteries and EV, and as both of you touched upon the BMS, so the chemistries are evolving, it will evolve. So, how can you make the BMS adaptable and future ready to quickly adapt to the new chemistries which are evolving and which you envisage that may be coming up in the near future? So over to you.
Sure. I think part of it I discussed a while ago that while we talk about the multiple chemistries which are coming up right now, what at Maxwell we are focusing on the developing the battery manufacturers EMSs which are agnostic to the configurations, right? Our algorithms, our software, it is such a modular the architecture, the algorithms which we develop, they adapt dynamically. And it's not only about the configuration. If you talk about, we just now talked about the B2G, we talk about the, you talk about the charge balancing and everything, right? What you need here is you need the core layer, which is on top of your hardware, which has to be actually agnostic to chemistries and still adapt to the changes which are happening. So that's where RBMS is becoming pioneer. But just to add on to what we were talking about, that how India can become the self-reliant, where like Pramod said, that heavy dependency is on the China still. Even in the BMS market, you talk about the any application from two-wheeler, three-wheeler, LP, L5, everywhere. So what I was saying that with respect to becoming self-reliant, right? We see that the monopoly has been from the Chinese side on the supply chain, as well as on even if you talk about the BMS, but are all policies which government is bringing in right now. You talk about the PMA drive, which is actually mandating all the important EV components to be manufactured within India, which includes the battery pack modules, BMS, MCUs, TCUs, all the advanced electronics, right? And that's where in endurance, recently we have actually set up a state-of-art battery pack manufacturing plant locally with a capex of 47 CR. And at the Maxwell, we are actually addressing all the advanced electronics like BMS, MCU, chargers. So like this, we are bringing it locally, and we have been doing from the day one of the inception actually. And not only this one, if we talk about the ecosystem in the supply chain also, there are 400 plus EV startups which are coming into the battery recycling, swapping. So the ecosystem is changing very fast, which is moving towards the self-reliant India only. And we should not forget about the lithium ion reserve, which we discovered in Jammu and Kashmir, right? Which can power 600 million vehicles actually, which is almost 6% of the global reserve. So there are right steps being taken, and India is becoming self-reliant in that. The disruptive supply chains, which are actually adding more cost right now to the whole ecosystem, they are being handled. And from our side, we are also doing our part of the job.
Excellent. So I think we had quite a bit of discussion here, and it has been just me asking questions. Now it will be a good idea to pass it on to the audience for the audience to ask questions to all of us. So I think let's get questions from the audience.
Hi, good afternoon. I'm Jiddu. I'm a research scholar from Bamarza School of Nanosciences Coaching, and we are working on lithium, sodium, and batteries and beyond. So my question is like, you talked about the normal chemistries which you are working on, and we were, looking forward for sodium as well. But even if sodium comes into the picture, it won't be replacing lithium, at least in the quite 1 or 2 decades, actually, because the usage differs. My question is, we are actually, usually following the commercial level chemistries which has been put forward and being used by the Western world. Like we started using NMC and LFC because most of the batteries, they are also coming like that. But beyond that, are we actually trying to explore ourselves other chemistries like cobalt-less, nickel-rich chemistries like high voltage, high energy density, LNMO kind of material? And also, what is the manufacturing level, outlook on systems like lithium sulfur, bringing that kind of chemistries into the picture? And one more question, like from the process point of view, if our academic scenarios are bringing out processes like, uh, uh, powder coating, dry coating methods for instead of slurry coating, and single crystal kind of methods, materials. If such a kind of things could be brought into picture, it will be a great change. So, are manufacturing sectors keenly observing this kind of development in the academic scale? And would you be interested in investing to bring such kind of things into the mainframe? Thank you.
Coming to his first question on the sodium replacing on the lithium ion, he's absolutely right that it can't be fully replaced, but some applications have high need for the energy density and the lifetime that sodium brings into account. I think that would be the best option. And coming to the process and the manufacturing industry that we are looking into is to bring in new chemistries inside and developing new processes, like he said, the dye coating method and the using of the polymer crystals would be the best option to take forward, because I think we have to go ahead of the supply chain right now, because what I see in the market is that the Western countries are continuously evolving and bringing out new vehicles or new discharge rates or new life cycles that which cannot be met with following them or following their path. I think it is best that we look into a space where we can overtake them and bring the cost in such a way that adapts to the Indian market.
If I may add on, so thanks, Guru, and a very very good pertinent question or set of questions. See, okay, first of all, as a researcher, I never take can't compete or can't replace. I would always say it is challenging as at this point of time. But yes, at this point of time, we are nobody's looking at sodium-ion battery completely replacing lithium-ion battery. It's more of a complementing lithium-ion battery. Okay, that's one. Second, some of the things like LNMO and high nickel cathodes when it comes to lithium-ion chemistry, they have been adapted and they have been tried and quite successfully also by some of the startups as well as established firms. But yes, they are yet to start cell manufacturing at a grand scale. So that was my first point in this discussion. Coming to the sulfur chemistries, so lithium sulfur looks very promising, but some of those bottlenecks are yet to be addressed for commercial uptake. Rather, sodium ion has moved closer towards a commercial uptake, and it has been in the commercial manufacturing in some countries, as we all know. So that's the scenario as of now. Now, coming to some of the fabrication processes, as you rightly said, dry coating, it's very important. There are challenges, but as a researcher, again, I would say that nothing is impossible. It is definitely possible to have dry coated electrodes. And in fact, some of the dry coated electrodes seem to perform better than the NMP based electrodes. In addition to dry coating, I would also add, can we get rid of NMC? I'm sorry, not NMC. I was using NMP. I meant NMP. So can we get rid of NMP altogether, even for the high nickel cathodes? Can that be possible? my answer is yes, that seems to be possible. So aqueous processing, that also brings down the cost drastically and reduces emission to a great extent. So yeah, so these are the various innovative electrode and also cell manufacturing which one has to adapt, and everything is happening, and I think this will all happen parallelly, and some of the aspects will be taken over by some industry, other will be taken up by another industry. So that's how it happens. Any other? Yeah.
Yeah, and just to add on, you have covered it very beautifully. See, the market is driven by the major OEMs. What we are seeing that the major OEMs, they are still moving from NMC to LFP. So moving from LFP to sodium ion will take a while, right? The major OEMs are driving the market right now. Unless the medium layer or the unorganized market, they try to invest heavily, this change will take a while. That's the take I have.
Because infrastructure or investment has already gone in one direction, right? That itself has taken so much effort, and vehicles have been already built on top of that. Now, if you have to switch to something else, the transition time, the cost of transition, all that also, because the economics plays a major role. Yeah.
I just have a quick question on the cell. When we talk about battery, we have in cell and out cell is the concept that we speak in the battery language, right? So efficiency versus cost. In the previous session, we had something like the lithium ion batteries coming down. The last 3 years, the costs have come down. On the other hand, we have to work on the efficiency, the power density, energy density, so called. And how does the material, what type of material? There are several materials that goes into the battery, not just anodes, cathodes. There are several graphite, silicon technologies also emerging, and we have wetting agents, dispersing agents, flexing agents that goes into the separator films, and so on. There are so many things that goes. So overall, when you want to offer a package, when you want to develop a new cell battery, how do these materials play a significant role in terms of efficiency as well as in cost reduction? And I would also add one question on the BMS system, because cell versus package, I think there are a lot of materials that goes to the durability of the overall system, right? So would you share some thoughts on that as well?
Sure.
Thanks.
See, for the cost of the overall battery, it involves right from the cell, BMS. When we talk about the raw material, which can bring the cost competitiveness, that is one thing. But what all we discussed here, that in my view, that the overall cost competitiveness for the overall battery, which includes a lot of these EV elements, comes from the local manufacturing and local availability of the material. But what you talked about the BMS part, yes, definitely. We are working on the configurations which can actually bring the cost competitiveness to our OEMs for their overall battery cost. And it does not only come from the hardware components, but also what is the longevity you are bringing to your battery, because it's a brain of the battery, and your TCO totally depends on that, how long it lasts. So we invest mostly on the algorithm sides in parallel to the components which are going into the BMS. But for the overall battery, I will still say that the cost competitiveness can only come from the raw material if we have the supply chain which is actually domestically available. Please.